ODA solid modeler can be used to perform various operations on DB entities. We present a demo for ODA MFC app to build a complex body from simple primitives using DB Boolean operation, revolution, and extrusion. First, we create boxes and make subtraction. Then we assign different materials on different faces of the resulting solid. Now we create a rectangular region, make revolve operation with custom angles to build a cylindric wall. We perform another subtraction between a cylinder and a box with materials, and unite resulting solid with the cylindric wall, and with the first solid body. Next, for two colored regions, we perform Boolean intersection. Copy and scale region and make subtraction to get a region with a hole. We use extrusion and get a solid representing walls. Then we add a roof using Boolean union. We unite this solid with the main building and add another small room. Finally, we add windows to the building and some decorations. As a result, we have created a nice art center. Notice that the resulting facility is a single DB3D solid. Rendering of DB3D solids in wireframe mode or in hidden lines removal mode requires calculation of faces silhouettes. We have been using quite inaccurate faces meshes to generate silhouettes. Now we have implemented silhouettes detection by geometry as a GE curve, which is much more precise using our ODA solid modeler. ACES BREP Builder supports torrent geometry now. What do we mean by torrent geometry? Generally, BREP data has some precision, meaning that all edges are on their faces and no loops are closed within some tolerance. This is a well-defined geometry, and ACES BREP Builder won't have any problems constructing a valid ACES body from such data. But more and more users try to use non-exact geometry. For example, there is a plane, but one of the edges is not on this plane. There is a distance from the edge to the co-edge on the plane. Other examples are loops. Loop is defined by edge geometry and should be closed and continuous. End position of current curve should be equal to the start position of the next curve with some tolerance. But sometimes loops have small gaps between edges and it leads to errors during data validation. Such data is supported by ACES and also may come from another geometric modeling kernel and you may want to use it. So, we added such possibility and ACES BREP Builder can now work with such non-exact BREP data using torrent geometry, torrent edges, co-edges, and vertices. Let's return to the edge which is not on the face. In this case, ACES BREP Builder calculates a distance between edge geometry and surface and creates a tolerant edge, TH, with TCO-edge, the new tolerance. Another example is a cube with gaps in loops. If loop has a gap, ACES BREP Builder creates a T-vertex in gap position, and tolerance for this T-vertex will be enough to close this gap. Of course, complicated cases have two issues: gaps in loops and edges not on faces. In these cases, ACES BREP Builder will use T-edges, TCO-edges, and T-vertices together to create a valid ACES body. And although it would be better to use geometry where all the loops are closed and the edges coincide with the co-edges and lie on surfaces, such improvements give us an opportunity to create valid ACES bodies from non-exact geometry. Thank you for your attention.